The sun, our brilliant, fiery star. Every second, it burns millions of tons of hydrogen, providing Earth with light, warmth, and energy that fuels everything from the smallest plant to the largest ocean currents. Without it, there would be no life, no seasons, no warmth, no us. The sun has been stable for billions of years, forming the backbone of our solar system and, indirectly, the foundation of every civilization humanity has built. But let's imagine the impossible for a moment. What if, overnight, the sun's comforting light vanished in a colossal explosion? What if, instead of billions of years, we had just one day left before the sun went supernova? How would we respond? What would happen to Earth and the rest of the solar system? Would any trace of humanity survive? Today, we're going to walk through this mind-bending, terrifying scenario and explore each stage of what would unfold. In a world increasingly connected by technology and knowledge, we often take for granted the constants of nature. But this question, what if the sun exploded tomorrow, is a reminder of the staggering power and mystery of the universe. So, let's explore a scenario that, while almost impossible, offers insights into our vulnerability, our resilience, and the cosmic forces that shape our existence. To answer this question fully, let's first understand how stars actually die. Stars like our sun follow a predictable life cycle. Our sun is a main sequence star, meaning it's in the most stable phase of its life. During this phase, it steadily burns hydrogen in its core, creating a balance between the inward pull of gravity and the outward pressure from nuclear fusion. But stars don't last forever. Eventually, even the sun will run out of hydrogen fuel. When that happens, about 5 billion years from now, the sun will enter a dramatic final phase. Without hydrogen to fuel fusion, the sun will start burning helium, which will cause it to expand massively, turning into a red giant. In this stage, it will likely engulf Mercury, Venus, and possibly even Earth. After shedding its outer layers, the sun will shrink down to a dense, hot remnant called a white dwarf. This transformation will be fascinating but far from an explosive supernova. Supernova explosions are reserved for massive stars, typically ones that are at least 8 times the sun's mass. Only these gigantic stars have the mass and energy needed to end their lives in a supernova. A rapid collapse followed by an incredible explosion that releases more energy in a few seconds than our sun will release in its entire lifetime. So, thankfully, there's no reason to believe the sun will ever explode as a supernova. But, for the sake of our thought experiment, let's imagine it could. What would happen in those first moments if the sun suddenly exploded tomorrow? If the sun exploded, the effects on Earth would be instantaneous. But ironically, we wouldn't realize it at first. Because it takes about 8 minutes for light to travel from the sun to Earth, we'd experience a brief period where everything seemed completely normal. For those precious minutes, life would go on as usual. People would go about their routines, completely unaware of the massive explosion that had just wiped out the sun. Then, abruptly, the sky would go dark. There would be no gentle sunset or gradual fading of light, just a sudden and complete plunge into darkness. Imagine the shock, the confusion, as the sun's light vanished from the sky without warning. That darkness would be accompanied by another invisible danger: gamma radiation. A supernova releases an enormous amount of energy in the form of gamma rays, which would reach Earth within hours, bombarding the atmosphere with lethal radiation levels. This radiation wouldn't just be harmful. It could strip away the ozone layer and expose us to dangerous cosmic rays. In just a few hours, Earth's protective shield would be compromised, leaving life on the surface vulnerable to the harshest aspects of space. But radiation is only part of the story. Let's take a closer look at what would happen to Earth itself. As soon as the sun's light and warmth disappeared, Earth would start cooling rapidly. The sun's energy is what keeps our planet's surface temperature in a comfortable range for life. Without it, we'd begin to feel the effects within hours. The temperature would plummet to freezing in less than a day, and within a week, it would fall below -70 degrees Celsius, -94 degrees Fahrenheit in most regions. The oceans, which play a critical role in moderating global temperatures, would begin to freeze from the surface downward, forming thick sheets of ice that would eventually extend hundreds of meters deep. Plants, the backbone of our food chain, would begin to die as soon as photosynthesis stopped. Without sunlight, even hardy plants that can withstand the cold would have no way to produce energy. Animals that rely on plants, from insects to large herbivores, would begin to starve within days. Entire ecosystems would collapse, and the chain reaction would ripple through every level of the food web. Human infrastructure would fare no better. Our homes, buildings, and cities are built for a world with sunlight, not for an unending freeze. Power plants would struggle to meet the intense demand for heat, and energy grids would likely collapse under the strain. Fossil fuels, nuclear plants, and alternative energy sources would buy us some time, but the inevitable cold would be relentless. Faced with such extreme conditions, humanity's only hope would be to find refuge deep underground or perhaps beneath the ocean. Underground bunkers, insulated from the extreme cold, could provide some protection. With enough power, food supplies, and infrastructure, people might be able to survive for months or even years. But eventually, resources would run out, and the world above would be too cold and inhospitable for even the toughest survivors. Another potential refuge could be deep-sea thermal vents. These geothermal hotspots on the ocean floor are warmed by heat escaping from Earth's core and are home to unique ecosystems that don't rely on sunlight. If we could somehow tap into these geothermal sources, small communities might be able to survive near these isolated oases. But even here, survival would be a short-term solution, as our ability to maintain such habitats would be limited by available resources and energy. In essence, survival in a world without the sun is a race against time. Even if some individuals manage to survive in isolated habitats, rebuilding civilization would be nearly impossible without the sun's energy. Humanity's existence would hang by a thread, reliant on dwindling supplies and the flickering hope of a new energy source. If the sun exploded, Earth's fate would be just one part of a much larger cosmic catastrophe. The explosion would release a shockwave that would travel outward, obliterating anything in its path. Mercury and Venus, the closest planets to the sun, would be vaporized instantly. Mars and the asteroid belt would be next, enduring severe radiation and gravitational disruptions. The outer planets, Jupiter, Saturn, Uranus, and Neptune, might survive the initial blast, but they wouldn't emerge unscathed. Radiation would strip away parts of their atmospheres, and their many moons could be blown off course or ripped apart. Even the Oort cloud, a vast region of icy bodies far beyond the outer planets, would be disturbed, sending comets and asteroids hurtling in all directions. Our once familiar solar system would be reduced to a collection of debris, rogue planets, and asteroid remnants, drifting through a radiation-soaked void. The cosmic clock of the solar system, marked by the sun's steady energy and gravitational pull, would be broken forever. The planets, if they survived, would continue on rogue paths through the galaxy, no longer bound by the sun's gravitational force.